Hello and welcome to my video on Img2Snes graphics converter. So in this video I will go over the graphics converter which I use for creating my graphics for the Super Nintendo. So this program depends on the SDL library to handle the window creation, and another library called tinyfiledialogs. The tinyfiledialogs library you don't need to worry about when building this if you're going to build it on Linux, as this has been statically linked, or it will be statically linked when you build it. That library is distributed as source code, so it's actually in with the main code. The Windows version is already built into an exe file for you, which will work with 32-bit and 64-bit Windows. So what this program does is will convert images to either 4, 16 or 256 color tiles, just like all of my other image formats. So I recommend you use whatever sort of graphics program you're happy with. For me, I use libs, which is a free open source graphics editor. So this is a font set here. So when you are creating tiles for the Super Nintendo, obviously everything is 8 by 8 pixels in size, unless of course you're in the 16 by 16 tile mode. So whenever I create graphics, I always put the color palette at the top left here. So when the graphics converter gets to work, it easily knows what colors it's working with per tile and can spot any errors for you. It also allows drawing graphics to be simplified as well, as you only work with the colors you're using, and it allows you to keep track of them easily. So as there is only 4 colors in this is a 4-color font set, and this would be used in, say, mode 1 or mode 0, or possibly mode 4, whichever allows for a 4-color tile mode to be used. So draw your tiles, and then all you do is you drag and drop them in, just like this. Hold down the middle mouse button to drag your image around. If the tiles are 8 by 8 pixels in size, you don't need to set a size here. And then you can either save the file normally and then jump to a folder and then say just like that, and then if there's no errors, it will tell you how many tiles it's saved. And then to check them out, go to whichever folder. So it was in here, and then if you open that with a text editor, there's your color palette, and then there's your raw bytes ready to put into an array for copying into the Super Nintendo. So one thing to note when you are creating raw arrays like this is the compiler for Img2Snes lib doesn't like working with large data files of bytes, and if you get anything over 32K in size, then it freaks out and then you'll have all kinds of issues. Sometimes it's nice to have the raw data like that so that you can actually see what's actually happening. And maybe if you wanted to update the graphics, it's as easy as cutting a line of bytes out and putting a new line of bytes in. And then another option we have is if we want to save it as a binary file. What this will do, again, we'll go into this folder here, and what this will do is it will create a .pic and a .pal file. So again, no errors there. Go back to the folder. And then you'll see we have two files here, a palette file. And then if we change the view here, we'll see the palette file has 8 bytes. So each color is actually 2 bytes in size because it's a word. So we know that there's 4 colors there. And then the pic file contains the raw tile data. With both of these, you can then drag and drop them into a Super Nintendo project that you're working on. So if I quickly bring this one across here, normally you would place them in the .res folder, which means it's like short for resources. And then to use the pic and pal files, you need to put some assembly in here, assembly code to include them here. So a format that I usually use, DB for data bytes, T for tiles, S for sprites, the color mode, and then T for tile or P for palette. And then you type in .incbin for include binary, and then the file path. And then another thing to note in here as well is you would have a section here. So you can think of these sections as actually a data block inside the Super Nintendo. So all of these files that you include here have to be less than 32K in size, as that's the maximum size each bank can actually be. If you've got a larger image, then you'll need to split it into 2 sections. And then you would read half of it and then give it one name, and then give the other half of it another name, and then put in skip. So this here, $8,000, is actually 32K in hexadecimal. So I will show you now what that actual image is. So if I bring this across here with some of my graphic sheets in, you see here we have a picture of Bowser. So if we open that one up in LibreSprite, and then you'll see this is absolutely massive. So there's no way the Super Nintendo could actually work with that image there. So we'll need to scale it down. So we'll resize this. So we'll say 224, which is the SNES's height. There we go. So this would fit height-wise on a Super Nintendo. However, there's still too many colours there. So if we select that and copy it, and then go to new on here, it gives us a blank image there. Fill that in and then paste that on top. Now what we need to do is resize that. there's no need to have that, all of that width. There we go. Now that whole image would actually fit on a Super Nintendo NTSC screen. However, we've still got too many colours. So what I'll introduce you to now is a program I'll recommend for fixing that. So if we copy that, and then the GNU image manipulation program, or GIMP as it's called, has a function in it. So we'll paste that in as a new image. It has some useful functions here under mode where we can select index. And then we select how many colours we want to convert that image to. So we'll go for 240 here. And then you've probably not noticed anything, but this is now actually 240 colours. Sometimes there's not actually a lot of change. So now what we'll do is we'll copy this. And then we'll go back to here, paste it over the top. You'll see that there's been a slight change in detail. And then we'll save this. I've already done this before the video, so I will navigate to where I have this. So this is a folder which I used the other day for my Game Boy Advance graphics converter. So what we'll do now is, this one here is the big Bowser. So if we go into properties, we can see it's 248 by 224 high. One thing to note is we have no color palette in this one. We don't know the exact colors, so not a problem. It's going to be 256 color tile mode. Then we will select this option here, which will take and build a color palette from the pixels in the image. And then we will ignore color 0, which will be, so if I open this up again, I'll explain this quickly a minute. So when we convert this image into a palette, what the program does is it starts at the top left, takes a color, adds it to a palette list, and then sees whether the colour it's found is already in the list or not. If not, then it adds it to that palette. So the top left will always be colour 0 in the palette. So when we want to convert this image, what we want to do is we put in the size here, so it's 248 across, 224 high, and in the demo I started it at 16. The reason for that is the demo which I'll show you, which is for mode 3 on the Super Nintendo, allows us to have one 256 colour tile layer and one 16 colour tile layer. So when I first was doing some code for that mode, I put in some smaller images first. However, seeing as this image is so big, we've got 240 colours here. So one thing to bear in mind is in 256 colour mode, the colour palette is robbed from the sprites to get the extra 128 colours. So there's 256 colours in total the Super Nintendo can have, but only half of them is for the tiles normally. The other 128 is usually reserved for the sprites, but in 256 color mode, the whole palette can be used for the tile sets. Another thing to bear in mind as well is the amount of VRAM each tile is going to use. So for example, a 4-color tile uses 16 bytes, a 16-color tile uses 32 bytes, and a 256-color tile uses 64 bytes. The tile range we can have on the Super Nintendo is between 0 and 1023, so that's 1024 tiles you can have in total. So potentially, if you try and have too big an image, you will run out of video RAM, as is the case with this image here. This image converts to about 56K. Bear in mind, you also need to put in tile maps for both of the layers if you're going to have them, plus a tile map for the background layer you're even working with, so you don't actually have a lot to play with if you go for large images. So we've got these. We don't want to include this purple color here, and then click on bin. As you can see, I've already saved him, so I won't save again. It's pretty much overwritten that, so I'll close this now. We'll come back to that in a moment, as there are some more things that I want to go through with that. So I will now open up my Mode 3 demo. So this here is the data folder here. So if I come across here and show you what I've got in here, so this is the project here. I will include the source code to this one for you to have a look at. This is the only project I will include the source code for, as the other demos which I intend to show you here are it's just me changing the data for some of the graphics for the other tutorials which I've already put out. However, this one, the reason why I'm showing it is because I haven't put out a video on Mode 3 yet, as of this video here. So you need to open the data folder here. You would drag and drop your images in here. So in this demo here, all of the tiles I've created, I've converted into pal and pick pairs. And then one thing special to note about the Bowser image is because it's so big, it's 55.6K, which actually takes up all of the sort of video RAM space, as you'll see. You need to use these commands here. So you read 32K first, and then you skip 32K to read the next part in. I don't know how exactly you would, whether you can go for super large images or not, as in files which are over 64K in size. You probably wouldn't even try, I guess. Probably no reason to do so. But anyway, so this top part, this section here, contains 32K of tiles for the top of our image, and then I know that the other half here will have enough space to load in the palette. And then this is simple enough, this demo. So this is using mode 3. Mode 3 has one 256 color layer and one 16 color layer. I was mucking around with this yesterday to double check things out in 256 color mode, as I added the functionality to the graphics converter without really doing much with it. So before I could kind of release the graphics converter to you, I needed to make sure that it did actually work. I didn't test everything out before, so this was another little test to make sure everything works. So we set mode 0, we enable background 0 and 1. So background 0, which is the 256 color layer, and background 1 is the 16 color layer in this. And then we simply, so although I said background layer, background 0, I do actually call it background 1 in here. So it is the first background, but the reference you use for it is actually 0. So we set the active layer we want to use, and then we can just draw one massive image here. And then if you do that, then this is what you end up with here, which looks pretty good. But the cost of it all is, if we have a look at VRAM here, we've literally taken all of VRAM. There's only a little bit of space here at the bottom for 16 tiles, and I had to turn off the other background layer as there was not enough space in the video RAM. So what you see in here is a graphic representation of all of the video RAM in the Super Nintendo. Impressive that it can do a full screen though. That's pretty cool, that. So I'll now show you the other version of the demo without using the Bowser graphics. So I will simply comment all of this out and then uncomment this and then rebuild that. Let's make sure I've got the animation bit in here. Now if I reload that, the text isn't working because I've not put the layer back. Let's do that. So I changed the where in video RAM the tile layers were. So if I alter that back and rebuild it, okay, that's changed it slightly. So I need to change that again. No, what am I doing wrong there? Wondering if I've changed something there. It doesn't matter anyway, it doesn't matter. So you can see there that you can work with 256 color tiles. So the next demo that I will go through is some sprites. So if we go back to the sprite demo that I released before, with this here, I'll show you how we can organize and change some of the graphics for the sprites. So I'll swap out Mario and the turtle dove for Sonic and Motobug. So I'll just navigate to the folder here. Initially the demo was supposed to have had these two anyway, but there was obviously a lack of video RAM to go around, so I wasn't able to do it in the original version. So I note with the sprites, all sprites are 16 color. So one thing to note is the easiest way to work with the sprites, and in fact 16 by 16 tiles, is when you're working with them, keep the image size to 128 pixels in width, as the video RAM in the Super Nintendo, when working with sprites and tiles, it always seems to map out inside to correlate with 128 pixels across. Now if you're working with 32 by 32 sprites, then they kind of need to be arranged like this in the video RAM. So for example, this would be tile 0 here, this is tile 16, 32 and so on. So there's 16 tiles across, so as long as you keep them to 16 tiles across, then you can literally just convert them into a block and then drag and drop them in. However, it makes tile streaming, which is the process of you load one tile in and then you just copy the new frame data over the location in VRAM of that data. That makes it very complicated to achieve. So when you're creating 16 color sprites, again put your palette top left and then have them arranged like this, and then you can easily use them on the Super Nintendo then. And then don't bother changing the size here. Literally put them to 16 color and then drag and drop them in, and then just save them as a binary. So then once that's saved, then it's a case of just dragging and dropping them in the let's open this project here. Go into resources, drop these in, and then we should be able to quickly just alter these. So instead of sprites 32, Save that. We should be able to just rebuild that. Now if we run that, there we go, we've now got Motorbug and Sonic. Of course the animation frames aren't that great, but it demonstrates how easy it is once you got a decent graphics converter to literally just swap out tiles and graphics. So that's pretty much all I will show you. There's nothing else really to go through, although one thing I will quickly show you is working with errors, just so you can see what to expect here. So I'll open this back up again. Bear with me a minute. So say your wait a minute, I've lost the folder here. Yeah, so you can move the this around with the arrow keys, and also drag it around should you need to arrange it. The idea with the size was to enable it to not take up the full screen, so you can kind of open a folder of your graphics on one side and then have this on the other, not taking up the full screen, just a quarter. So we've got a tile here. It's 4 color, but we've not completely set all of the colors in the color palette there. So if we go to save this, there we go. So its color format is red, green, blue, and alpha, and it's found illegal color, and then this has told us what the color is. It's in tile 0, and then it's at pixel 2.2. So if we open this up in LibreSprite now, and now we can see, oh okay, so the color it's found is that one there. So if we go in the colors here, and then we'll see that that color is red, and then we can see, we've not put it in, so let's put that one in and then save that. Okay, so that's not saved, so we've updated it now, so let's bung that one in. So it's found 3 colors now. If you left click, it zooms in. Now if we save that one again, okay, we've got another error. So let's bring our image back, and this time it's at 5.2. So if you notice, when I move around in LibreSprite here, it tells me which pixel I'm on. And if you press I, it goes to the pipette or eyedropper icon. There you go. We're at 5.2 there, and then it's black. So we've not included black. So if we put that one in there now and save that, bung that in, found 4 colors, zoom in again, click on save, and there we go, and now that will work. When you cancel it, it still saves a blank tile. You'll just have to go in and delete that afterwards. So that's it for my Img2Snes converter video. I'll leave the source code and everything for everyone in the description to the video. Hopefully you'll find this useful. Let me know if you have any issues, and thanks for watching.